Well, here I'm going to go over the answer key to Exam 4, Math 3A, Hartnell College. This is the fall 2015. For this antiderivative here, we would be using u substitution. So you let u equal the denominator. The derivative of that is going to be 2x plus 5 dx. And then if you notice, this just needs to be multiplied by 2, and then it's going to match this numerator perfectly. So multiply both sides by 2 here. This will be 4x plus 10 dx, which is exactly what this numerator has, so we're ready for the u substitution. When I do the u substitution, there's going to be 2 du in the numerator. I'm going to go ahead and factor that 2 out. And what would be left with is du for the numerator, and then this would just become u in the denominator. So the antiderivative then would be 2 natural log of u plus c. Don't forget the constant of integration there at the end. And the last thing is replace the u with x squared plus 5x plus 1. And that one is finished. So these problems are worth 8 points apiece. On to number 2, which is also going to be u substitution. So let u be the denominator. And once again, take the derivative. The derivative would be 4x cubed dx. And this matches the numerator, except it's got this extra 4, so multiply both sides by 1/4. It will say x cubed dx can be replaced with 1/4 du. And again, I'm going to factor out that 1/4 when I make the u substitution. The top part will become du. The bottom part is going to be just u. So once again, the antiderivative is the natural log. This one will be 1/4 the natural log of u plus c. There is one small technicality. I'm supposed to put the absolute value because you can't take natural log of a negative. So technically it's supposed to be 1 plus x to the 4th in absolute value, although since 1 plus x to the 4th can't be negative, you actually don't have to put this absolute value. All right, so that one's done. Another 8 points. Number 3 is also going to be a u substitution, but it's going to be a little bit, just a little bit more work. So with this, I would let u equal e to the x. For one thing, e to the x is what's inside of this function. And also, when I take the derivative, then du would be e to the x dx. And this matches what's in the problem, e to the x dx, perfectly. So this is what I should be using. The only thing is, what do I do about this being a 2x? Well, what I could do is use algebra and rewrite this as e to the 2x is the same thing as having e to the x being squared. So when you have an exponent raised to an exponent, you multiply, so this is the same thing as this. And now I'm ready for the u substitution. So it's going to be integrate. The top part is just going to become du, and the bottom part is going to become 1 plus u squared. And then this is one of the antiderivatives that you have memorized. This is tangent inverse. So it's going to be tangent inverse of u plus c. And last, replace u. So the final answer is going to be tangent inverse of e to the x, and then plus the constant of integration. There's another 8 points. On to number 4. Once again, u substitution. So the inside function is natural log of x, so this is what u will equal. The derivative of the natural log is 1 over x dx, and this has a dx on the top and an x on the bottom. This has a dx on the top and an x on the bottom, so they match perfectly. So we're ready to do the u substitution, it's going to be integral cosine, and then the inside part becomes u, and then this part, dx over x, gets replaced just with du. So the antiderivative is going to be sine of u plus the constant of integration. And last, replace u with what u is equal to, so the final answer is going to be sine of the natural log of x plus c. All right, on to number 5. As you guessed it, it's going to be u substitution. And I'm going to let the denominator be the u. So u is going to be 1 plus secant of x. The derivative of that is, well, the derivative of 1 is 0. The derivative of secant of x will be secant of x times tangent of x dx. And then notice this and this match up perfectly. So then it's ready for the u substitution. The numerator, all of this stuff gets replaced with just du. The denominator is just a u. So once again, the answer is going to be the natural log plus c. And again, technically I'm supposed to put this in absolute value. I often forget the absolute value. So this is going to be natural log of secant of x. Oh, I forgot my plus 1. I'll just put it at the end. It means the same thing. There we go. And then plus c. Okay, then on to number 6. So with 8 points apiece, that means the first page was worth 48 points. So let u equal the inside function, so that's going to be the x squared plus 4x. The derivative of that will be 2x plus 4 dx. And then if you compare this with the numerator, we actually need to cut this in half. So multiply both sides by 1/2. This side will become x plus 2 in parentheses. And then this matches the original problem exactly. So when I make the u substitution, I'll go ahead and factor out the half. The top will become just du, and the bottom is the square root of u. Now in order to integrate this, you can't use natural log, but what you do is rewrite it as u to the negative 1/2. And then to find the antiderivative, add 1 to the exponent, which will be a half, and then divide by half. So it's going to be, there's a 1/2 already, then it's going to be u to the positive 1/2, divide by positive 1/2, and then put plus a c. And then here, either invert and multiply by 2, or notice that 1/2 divided by 1/2 is going to be just a 1. So this turns out to be just the u, which was x squared plus 4x to the 1/2 power, or you could put square root. Either way is fine, but don't forget the plus c. All right, then quickly on to number 7. So what I do is say, okay, we need to first of all find delta x. So that's going to be b minus a divided by 10. So that's going to be 1/10. And you could use decimals or fractions. I'm going to use fractions. Then what that means is take the interval from 0 to 1, divide it into 10 equal pieces. So this would be 1/10, 2/10, 3/10, etc. until you get to 9/10. The next part is find the midpoint. So the midpoint right here between 0 and 1/10 would be 1/20. And then this one between these two would be 19/20. And then we need to add up the area of 10 rectangles. And I'm going to use the calculator and do the sum sequence. The height of each rectangle will be the function. The width will be delta x. And then x goes from 1/20 to 19/20 in increments of delta x. And when you put all of that in the calculator, you'll find out that the answer is 0.882. And then you could even graph the original function, have the calculator integrate, and you should find the answer very close to this. For this next part, there's two parts to the fundamental theorem of calculus. One is that the derivative, so you would need to explain this in words, but you could also write it. But explain means explain it in words. So I'll say the words, but I'm not going to write them down. So one part of the fundamental theorem of calculus is basically that integration and taking the derivative are opposites of each other. In symbols, it would look like this. Integrate from a to t, where this is some function. And then, oh, excuse me, this should say a to x. Here, I've got an eraser. And then take the derivative of this, and you'll get the original function back again. So taking the derivative and integrating are opposite operations. You'll get the original function back again. Another idea is that if you're supposed to integrate from a to b, some function, which literally means find the area under the curve between a and b. And suppose that capital F is the antiderivative. So if you find the antiderivative, you plug in b, you plug in a, and subtract those two, then that will give you the area under the curve. All right, that one was worth only 4 points. All the rest are worth 8 points. For number 9, so number 9, it was find the area under the curve 2x squared minus 9x plus 11 on the interval from 0 to 4. So this was just simply integrate this function from 0 to 4. So the antiderivative would be 2x to the 3 over 3 minus 9x squared over 2 plus 11x, and that gets evaluated from 0 to 4. So you substitute the 4 in there first of all. It's going to be 4 cubed over 3 minus 4 squared over 2 plus 11 times 4. When you substitute the 0, it contributes nothing to the problem. And the final answer turns out to be, 14.667 or 14 2/3. All right, then on to number 10. Find the area between these two curves. So if you were to graph these, negative 2x squared plus 9x plus 5. Oops, I must have hit the 9 twice. 9x plus 5, and then x squared minus 2x plus 6. You'll see that one is a parabola opened up and one is a parabola upside down. And what I was asking for is this area that's between the two, so this area. And you can either use the calculator or you can use the quadratic formula to find out where they intersect. So I already did that, and I found out that we're finding this area, and then this, I actually used the calculator. This is where x equals 0.093, and this intersection point is 3.573. So integrate, and now you have to subtract the two functions, and it needs to be the top function minus the bottom function so that we get a positive answer. So the top function is the upside down parabola, that's this one, negative 2x squared plus 9x plus 5, and then subtract the other one, evaluate from 0.093 to 3.573. So I would do the algebra first of all, and that is combine like terms. So in here, there's going to be negative 2x squared and another negative, so negative 3x squared. Then combine the x terms, and this would make it a positive 2x, so there's a grand total of positive 11x. And then a 5 minus 6 would be negative 1. So the antiderivative would be negative. So this one would be x to the 3 over 3, but then it's going to cancel this. It just becomes x to the 3. The middle one would be 11x squared over 2, and then minus x. Evaluate it from 0.093 to 3.573. And when you plug in these numbers and then subtract the answers, the final answer is 21.074. Oops, sorry, 21.074. And that was another 8 points. Then on to the last page of the test. The area is between y equals e to the x. So if you put on the y-axis, it crosses at 1, and then the e function looks like this. And then y equals 1 would be this line. So it has to be between these two. So it's got to be something like this, area. Then between x equals 0 and x equals 2. So the area that's being talked about is this area in here. Okay, then for part A, rotate this about the x-axis, like this. And so then I would set up the rectangle, representative rectangle for that area like this. Since this rectangle is perpendicular to the axis of rotation, that means that it's either the disk or the washer method. Since there's a gap, this is going to be the washer method. And writing down the name is one thing that you should do. I'm using the washer method. That means that I integrate pi and then the big radius squared minus the small radius squared. Okay, so for this one it's going to be integrate from 0 to 2 because we're talking about integration with respect to x. So this rectangle needs to start over here at 0 and then move to the right until it eventually gets over here to 2. The big radius would go from here to the top of the rectangle. So that is the e function. So it's going to be pi, and then the e function gets squared minus. Now we need the small radius. The small radius would go from the axis to the bottom of the rectangle, and this is a length of 1 the whole time. And you don't have to evaluate the integral, just leave it like that, you're done. There's another 8 points. Now take that same shape and rotate it about the y-axis. So let me just quickly draw. It looks approximately like this. So here's the area that's being rotated, then rotate it around the y-axis. And I would go ahead and leave the rectangle still like this. Now, when the rectangle is parallel to the axis of rotation, that's the shell method. So I just remember that's the formula. Integrate 2 pi, the radius times the height, and then it's going to be dx or dy. In this case, it's going to be dx. Again, the rectangle needs to move left and right between 0 and 2. So I'll actually be integrating from 0 to 2. So the setup is integrate from 0 to 2, 2 pi. The radius is measured from the axis over to the rectangle. So this is the radius, and that would be a length of x from here to here. And then the height, oh, you know what? This one didn't say the y-axis, sorry. This one actually said rotate about the line x equals 4. Okay, that's That's fine, just go over here to 4. Yeah, what that changes is this part is not just x. So, okay, well that's good. This part is x, but if I'm rotating from this line, I have to go from here over to here. And then this length, or this radius, would be 4 minus x. So this should actually be 4 minus x. And then I need the height. And the height of this rectangle comes from the top function minus the bottom function. So the height is going to be the e function minus the 1. The e function minus the 1. And now that I realized that it goes over here to 4, I've got 4 minus x, I've got the height. That should be 0 to 2 and 2 pi. Now this is just a big old multiplication sign right here. There we go. All right, then on to the very last problem. If this is the velocity, then to find distance, you need to integrate it. And so we're going to be integrating this function. That part is going to be straightforward. The only thing is, velocity can be positive or can be negative. And so if you need the total distance, if there's ever a time when the velocity is negative, then you're going to have to take absolute value of that or negative of that. So what I'm going to do just quickly is graph the function negative 16x squared plus 100x plus 6. And I don't need any negative time. And velocity could be negative or it could be positive, so I suppose I should leave this negative 10 to 10 and then take a look at the graph. And you'll see that on the interval from 0 to 5, so right here is 5, right here is 0. This thing went up and it's positive until 6.2 or something like that. But between 0 and 5, it's always positive. That means that all you have to do is integrate from 0 to 5, and that's going to be the total distance. So this antiderivative would be negative 16 and then t cubed over 3 plus 100 t squared over 2 plus 6t evaluated from 0 to 5. So when you substitute the 5, it would look like this. This would reduce to be 50. And then 5 squared, 6 by 5. And when you substitute in the 0, it's going to give you nothing, cutting our work in half. And then the final answer is 613.333 feet. For the last problem, I did not grade it because it turns out it's the exact same thing as part A. My thought was that I had made up the problem so that 5 was over here, and you were going to have to do two integrals, one when it's 0 to whatever, and then the other one. But it turned out that it actually went like this, so the whole thing is positive, which means the answer to A and B are exactly the same. So I didn't even grade B, I only graded A.